Hello everyone, welcome to my next tutorials related to the Setfos softwares. In this tutorial we will be simulate thermal properties like average temperatures, heat flux, how the solar cell behave when we take a different thermal value. Because in a previous video you have already seen absorptions modules, drift fusion modules, scattering parameters. You have already simulated different type of properties like external quantum efficiency, energy yield analysis, absorptions, layer absorptions, open circuit voltage, fill factors, power conversion efficiency, etc. So if you have not seen it my previous video, please check out the playlist, and Setfos playlist have given, so you can check. In this video I will major focus about the Perovskite thermal projects, and I will show how you can simulate thermal properties. I'm going to open Setfos software. It is a Setfos graphical user interface. Who has not seen it my previous video, they can check how we take different exact descriptions about the tools. Like in here you can create new projects when you click on this, and existing examples you can see from this sites. If you want to save your projects, you can save for the examples tabs and layer stack tabs. It is a materials database with valid research papers they have taken, so you can check. And passive optics modules, it is a 5 modules of the Setfos software, because Setfos divided in the 5 modules: absorption modules, emission modules, scattering modules, drift fusion modules, and thermal modules. I will simulate in here thermal properties, so 8 modules are necessary parts in this video. It is a 4 mode, you can see in here. In here you can create your layer stacks, and stack preview you can check in this side. It is a input tabs where you can provide all of the inputs parameters for modules, layer stacks inputs, and scripts. It is a console view when you simulate that projects, you can see, and it is a results. It is a brief discussion about these tabs. You can check my first video, I will explain each of the tabs. Now I'm going to create one of the perovskite examples, and then I will simulate thermal properties. Like first you can take air, then glass, then one of the conducting oxide, one of the HDL layers. It totally depend on the user which type of structures they want to create, so they can take accordingly that's the layer, and then they can provide inputs one by one. Perovskites, ETL layers, PCP, metal, copper, and airbags. So this type of layer stacks you can create, and in here you can see that stack preview, but now you can provide in here that thickness parts as well. As you can see different units are available, but you can give in here the units one by one. Like for the glass you can give in here the 0.5. I'm considering in here example value, but if you want to change you can change. For each layers you can take different thickness value. Now you can see that a stack preview arrange according to your thickness. After this you can give in here the refractive index files, which layer is wavelength dependent, so you need to import files, and absorptions parameters as well. As so first you can give in here air to constants value we have taken 1, but for glass you can take in here 1, and if you want to change you can change, but I'm considering in here the same. And glass which will incoherence, and ITO you can give in your refractive index file. You can see different refractive index files are available, but you need to import that the same files ito.nk. Same one by one you can import. For the perovskites you can take one of the layer. You can see different perovskites files are available. It depends on the users. If you want to edit your data and want to give in your own value, you can give in here this, and then you can create your new files. If you want to export your data, you can directly export from this tab. Same for the C60 you can import BCP, copper. You can see we have imports different refractive index files. But now you need to provide in here as well as absorption parameters, so you need to activate that absorption modules, and you can see it is a absorption settings tabs. You can see different wavelengths and energy parameters. You can see we can select range in here. It depends on the users which type of range they want to select in here, so they can select accordingly. Defaults parameters, according to that ranges result will be come in that absorption sites. And if you want to change the spectrum files, you can see location, date and times, and latitude, longitude, elevations, so you can check. And the spectrum files you can also select. In default spectrum files we have selected in here, and after this you can give in here electrical value. Now you can also activate electrical module, and after this you need to provide in here the electrodes, and in between the electrode you need to provide semiconducting layer as well as their inputs. So you can select in here the ITO as electrode, and you can see injections model. Different injections models are given. It depends on the users which type of model they are working, and theory parts are as well as given in here. Boundary conditions you can see, but we selected an example value. You can take in here 5.4. We considering in here the BCP as a bottom electrode, and then you can consider in here work functions 4, and in between electrode you need to give in here the semiconducting layer, and otherwise it will show error. So you can select semiconducting layer. Now you need to provide in here the semiconducting value. You can see different electrical materials files are available, so you can import one by one. When you imported your files, so data automatic fill in here. You can see different mobility models are given, directed constant energy levels, so you can check density of state types. Same you can provide in here the perovskites, charge, excitant, traps, trap coupling, mobile ions, recombinations. Now you can import for the C60, excitant, traps. If you want to give that value, you can give in here. When you provided that input files, now you need to move on this electrothermal settings. You can see different modes are given: steady state, transient, AC, intensity modulated, photo current spectroscopy, and voltage spectroscopy. So you can select in here like transient signals. It depends on the users which type of parameters they are working, so they can activate accordingly. Like for the steady state, you can see different tabs are given in here. For device operated voltage, as per examples we have selected in here 0.8. Bottom electrode for the change polarity. Temperatures you can select in here 300 Kelvin. You can consider in here traps, doping, mobile ions, which type you have active in this input tabs. So you can consider in here, so they will consider that value. It is only for the electrical parameters, which type of parameters you want to select. Now you can activate thermal module as well. And when you activate thermal modules, so you need to provide in here the boundary conditions like this. You can see thermal boundary conditions and thermal conducting. When you enable thermal boundary conditions, you can select in here the 300 kelvins, and if you fix that temperature, that means a boundary condition where the temperature is held constant at a specified value regardless of the heat generation or heat flow. So if you want to do this, so you can enable this type. And otherwise, when you select the convective boundary, it means a boundary conditions that models heat transfer between a surface and surroundings like air and water etc through convections. When you go on this transfer coefficients, so you can provide in here that's 100, and you can check in here the units as well as. It means it quantify how effectively heat is transferred between a surface and surrounding fluid by a convections. And heat capacity, that means ability of the boundary to store thermal energy, like higher value temperature change slowly and lower value temperature change quickly. A radiative boundary, that can be say heat loss by thermal radiations like infrared emissions. So if you want to do, you can enable. I am considering example value, so I am not taking this. And emissivity describe how efficient a surface radiates heat. So these different tabs are given. So if you want to check that example, so it is exact information, so it is a theory part. So you can also check why we are using this type of value. So here we are considered as the thermal boundary conditions, and this type of value you can see. For the air bottom, you can also select thermal boundary conditions like 300, and convective boundary you can take, and transfer coefficient we can give in the 100. And now in between you need to select thermal conductings, like you can see thermal layer structures. If you not provided this value and things, so they will show the error. So one by one you can take thermal conductings. And now you can provide in here the thermals value, thermal conductivity and heat capacity. Like you can provide one by one each of layer value. In here thermal conductivity means it is just a material property that measure how easily heat can flow through a materials. High thermal conductivity means heat spread quickly, and if you take in the low value, so heat spread slowly. Thermal conductivity value 1.05, and heat capacity we can take 2.1 exponential 6. If you want to change the unit, you can change, but I'm not changing, I'm taking example value. And as per the heat capacity we have already discussed, that means amount of heat required to increase the temperature of object by 1 Kelvin. And same you can give one by one each of that thermal conductivity value and heat capacity value. Like for the ITO you can give 0.84, and heat capacity you can give in your ITO 1 exponential 6. For the HTL layer you can give 0.5 as the same, and for the heat capacity you can take 1.8. If you want to disable some of the parameters, so you can disable this. Like I'm taking here the disable Thomson heatings. That means we will ignore that Thomson effect. That Thomson's effect means when electrical current flow between these materials. So if have the temperature gradients, additional heating or cooling can occur. So they will ignore that effects when you disable this. Now you can take for the perovskites, and heat capacity you can take 1.5 exponential 6. Also you can disable, it depend on the users. I am just taking the examples value, but if you want to change you can change. Now you can provide one by one 0.5 heat capacity you can give in here, that's 3 exponentials. You can also disable these Thomson heatings, and BCP you can give. For the copper you can give at the 401, and heat capacity you can give in here the 3.43 exponential 6. Airbag you have already selected. You can check the value one by one. If you want to change any one of the parameters, so you can change. If you want to give in the SIP settings, so you can provide. You can see different SIP parameters are available in here. Thickness, electrical materials, recombinations, which type of parameters you have provided. If you want to shift thermal material property, you can also shift. You can select in your range, and you can select step as well as. If you want to change any parameters in here, you can see on the scripts. In here you can provide your project name, and then you can simulate. Now you can check one by one each of the results: built-in voltage, current balance, device currents. You can see different curves are available in here. Electrical power, power conversion efficiency, band diagrams, HOMO, LUMO. charge density, charge generations, electrical field, mobilities, potential, recombinations, and trap capture rates, numerics, photocurrent, stat contributions, absorption profiles, passive optics properties you can check in here, absorptions parameters you can see, layer absorptions, you can export image as well as data. If you want to compare with another ones, you can compare, you can see that ranges, reflectance, stat contributions, transmittance data, it is average temperatures, heat flux, total heat flux plus bottoms, heating powers, total heatings, so you can check in here, heating source, temperatures, you can see, and click on this x-axis, y-axis you can change. Now I'm going to end this video. If you have any query related to the thermal properties, so you can directly connect with us. You can mail that given in the description box and end of the video. Who has not seen it my previous video, please check out the playlist. Thank you very much.